My name is Terrence Barkin. I'm the Executive Director of the Graphene Council, and we're very happy today to be hosting our webinar presented by Haydale, one of the most experienced and knowledgeable companies in the graphene sector, on an application that they've developed of graphene-enhanced composite tooling. Haydale is a member of the Graphene Council, and we're very pleased to have Simon Green from Haydale to go ahead and give us our presentation today. For those of you who are not familiar with the Graphene Council, we are a global trade and professional body. We're an independent organization that covers all things graphene, working not only with graphene producers, but those companies and individuals that use graphene, as well as the research community. And with that, Simon, I'll invite you to go ahead and give us your presentation. Tell us about what you guys have developed at Haydale.
My pleasure. Good afternoon, everyone. Thank you for joining us. I'd like to just thank Terrence and the Graphene Council for the opportunity to share this presentation with you. I hope you find it interesting. Haydale has a global footprint of 5 locations across the UK, US and Asia. Haydale's head office is in Ammanford in South Wales, where our functionalisation of nanomaterials are produced and master batches, inks and other products are manufactured. Haydale Composite Solutions is based in Loughborough in the Midlands. It's an application centre where composite materials are developed for customers. We have 2 further sites for sales, production and product development in Korea and Thailand, serving the APAC region, and a long-standing silicon carbide production facility in the US, located in North Carolina, that produces silicon carbide whiskers for cutting tools and coatings. A little bit about the technology of HD Plus. HD Plus is our patented functionalisation process that unlocks the performance of graphene and enables the production of our resin master batches for composite applications. Without this process, none of our prepregs would exist, so it really does underpin every product that Haydale produces. So, the functionalisation process. Haydale has a vast experience in selecting the correct nanomaterial best suited to the end application, whether it's mechanical, electrical or thermally enhanced, as in the tooling system. We then select the correct chemical group and level of functionalisation to apply to the surface of the nanomaterial during the plasma process. HD Plus is a high volume process capable of delivering several tons of functionalised nanomaterials per annum through our fleet of reactors ranging from 60 litres to 1400 litres. We take the nanomaterial, be it graphene, CNTs or boron nitride, of which we have characterised more than 250 types, and then functionalise it for purpose. It then either goes into the next phase of the process or is shipped back to the nano supplier, as we do offer a total functionalisation service. We combine it with carrier matrices to suit the product group, composites, inks, elastomers and so on. And then either it's sold on as a semi-finished product, or we process it further into a final product for end use. Here's a short video which should demonstrate nicely the effects of functionalisation on inert nanomaterials. So on the left, you have a non-functionalised standard graphene just dropped into water. So a very simple experiment, and you'll see that it agglomerates, sinks to the bottom. It doesn't want to mix. The same nanomaterial has been now treated for an hour in our reactor just for dispersion quality, and you'll see that the difference is quite remarkable. And this repeatable dispersion is really key to getting nanomaterials into resins or carrier matrices. Okay, onto the products. So it wouldn't be fair to talk about the tooling prepreg without giving a little recognition to Briggs Automotive Company. BAC was the first automotive OEM to embrace graphene composites in both the body panels and their tooling. And the Mono-R program is where Haydale first developed the tooling product. But although Mono-R is a limited edition low volume series, this is really where the product development began. So onto the tooling. Composite tools are not as robust or as long lasting as metallic tools. So the challenge was to improve the product by incorporating graphene into the resin system. The Haydale tooling system was designed with the following performance uplifts in mind. A 30% increase in thermal conductivity, which means that the tool equalizes hot and cold spots quickly, which provides options for thermal management of components. A significant reduction in the mismatch of coefficient of thermal expansion, the CTA, between materials when compared to metallic tooling. It gives an improved homogeneous cure, which will deliver tighter tolerance parts. It provides a better surface quality. It extends the tool life. You have less frequent tool changes and reduced tooling costs. However, this needed to be proven in the real world in a volume application. As the Mono R was a limited edition program, the early production volume of parts did not provide any longevity numbers, and we needed to trial in a much higher volume application. Haydale approached Prodrive UK, and they kindly offered to assist us with this, and they agreed to produce a tool for one of their higher volume programs. And as you can see from the testimonial provided by Matt Bradney of Prodrive, the results of the trial really did deliver. The ongoing trial has produced more than 500 parts from the first tool with no noticeable deterioration in the tool surface. The tool is still in use at Prodrive, so the final number of parts is yet to be confirmed, but it's in excess of 500 now. This is being monitored, and we are very excited to know the final number of cycles. Something that will be key, kind of on everybody's radar, is sustainability. So is this a greener solution? We think so. With the composites industry becoming more heavily focused on reducing its carbon footprint, this system has a very strong case in driving towards that goal, which should be of interest to the automotive and aerospace OEMs and high volume industrial manufacturers, as they all have environmental targets to meet. Any product that lasts longer and reduces raw material usage and energy consumption is therefore more environmentally friendly. Any product that reduces waste material and the use of consumables inevitably reduces the impact on the environment, either by the cost of recycling or the cost of going to landfill. And at this time of increased cost for production energy and a drive to use less fuel for shipping, any reduction should be well received. So how does it stack up? There are several elements that build up the cost of producing a tool. It's important to factor in the overall cost saving of the associated elements when considering a graphene-enhanced alternative. Here we see examples of where the reductions can be made, overall making it a greener and more cost-effective solution. The tooling prepreg is available in all the standard carbon fibre reinforcement weights, 200, 650, 800 or 1000 GSM. It is processed in the conventional way, so there are no changes to your standard production processes. And the product is available in high volume through a fully accredited and established UK supply chain with global shipping available. Some things to be aware of. This system is not for every tooling application, as the initial material cost is higher than standard tooling prepreg. So on low volume production runs, it may not be as attractive as standard lower cost materials. However, it does begin to make real commercial sense when you consider it for programs with multiple replacement sets of tools. The higher the volume of parts, the more cost effective this solution becomes. And the more complex and costly a tool is, then the extended life really begins to pay off. Reducing the cost for replacement tooling can be the competitive advantage that secures a program over your competition. And considering the reduced environmental impact, the increased process efficiency and long-term cost reduction of this system, we believe it will be a winner. Thank you for your attention. I'll be happy to answer any questions.
That's great. Well, thank you, Simon. That was very concise and very useful. If you want to stop sharing your screen, it'll just be you and I chatting. So first of all, I want to thank you for sharing that. Again, it's quite clear cut. I think what's very interesting is that last one on the economics. You know, most people are going to ask you straight up, and I appreciate you sharing that. It showed, you know, a 30 to 50% increase in the cost. for the prepreg materials themselves, which contributes approximately 10% increase to the cost of the tool. But yet doubling its life, obviously that's extremely attractive. I think some of the other things, and we've talked about this before, that's quite interesting is also kind of the behavior in a shop where you're actually making these parts is about how people treat the tools. Can you talk a little bit? What has been the impact of having this graphene-enhanced composite material on the release, right? So when you have the part, a lot of times the tools will get damaged if you can't get a good release, and then the crews are using hammers and other things they shouldn't use.
Pry bars.
Yeah, right, to get the part out. Can you talk a little bit about that? Because I think that's the real world use and how the tool's used on a shop floor is, I think, interesting to understand.
It is, and this subject actually was raised by a potential customer who was looking at this material, and he said, "I'm not convinced I want to outlay for more expensive tools because of the way some of the operators treat our tools on the shop floor." What has been fed back from customers using this is that it releases really well and it maintains its surface quality. Now, we know for a fact that graphene is a natural lubricant. So putting graphene into the resin system appears to provide slip on the surface. So the release seems to be better.
Excellent. I mean, that's really important. And I think the other statistic that you shared, is after 500 pulls, you're not seeing any degradation in the surface or the finish of the part. How important is that matching of the thermal coefficient? And this is, for example, another application. If we look at the wind turbine blades, for example, which have these huge parts and variable thicknesses and all sorts of things, where the heating and cooling of the parts is not even. How much of an impact does graphene have on matching that thermal coefficient?
When this was originally designed, it was designed with that in mind, and the thermal conductivity increase to equalize the hot and cold spots was deliberately targeted for this. Now, we can prove that that's the case. We've got the data sat behind that, but it is really, really important. Now, a few years ago, and this one always sticks in my mind because it was a prime candidate for this material pre-COVID, there's two suppliers making chassis parts that need to marry up. So they're not done in the same facility. They're done by two different suppliers. And when we were touring one of the sites, they were saying, we've got the mold tool and we've got this. Every time we bring it out, we pop the chassis out, it's out of tolerance. So I think in applications like that, where it's quite a complex part, equalizing the cure is going to produce a part that actually fits in a lot of cases, because these guys were having some terrible trouble with it.
And I'm not sure, I don't think we've talked about this before. So here we're talking about an example of using this graphene-enhanced prepreg in the production of the composite tool. The parts that are being made, are those also using graphene, or are these non-graphene enhanced parts?
The parts for the BAC are graphene enhanced as well. They are a different nanomaterial blend, and they were aimed for other specific properties, mechanical uplifts. Interlaminar shear strength was the primary driver behind that design.
Absolutely, absolutely understand that this application can be used where the parts themselves are also enhanced with graphene. Or in the case of BAC, I believe they were able to eliminate a layer of carbon. Is that correct?
Correct. Yeah, they redesigned. Once they'd got the mechanical properties up, they were able to take a layer out and redesign and use localized reinforcements instead of an entire layer of reinforcement.
So that reduces material cost, that reduces labor, and that reduces weight.
Yes. I think Absolutely. It was around 22 kilos out of a body set of panels. That's what they took off that car.
Well, if we think of UAVs and drones, where aerospace applications, satellites, anything that's going into orbit, obviously every ounce that's saved is hugely valuable. But I want to come back to the question: using this graphene enhanced tool doesn't necessitate that the part itself uses graphene as well. It can be used with non-graphene enhanced parts. Is that correct?
Absolutely. It's designed as a standalone system.
Excellent. Now, there is a question about recyclability of material, and recycling in composites itself is a hot topic, but do you have any data or information on how the graphene affects the recyclability of the material?
Okay, so as the graphene is held within the resin system, so that's captured separately to the carbon fiber. So when it goes through the traditional recycling routes, there's a company in the UK that probably we all know, they use a pyrolysis process. So when you burn the resin off the carbon fiber reinforcement, you take the graphene up in the fumes into the filtration, and it still leaves the bare carbon fiber, which then goes off into the needle punching or felting processes. So there's no real change to the recycling process. It doesn't reduce your ability to do it.
And I think it's important for people to understand, for those who are maybe not into the details of applying graphene, people are quite resistant because they've heard that graphene's quite expensive, which I think that perspective today is a bit out of date. But also the amount of graphene that you need to drive these kind of performance improvements quite small. Now, the question I'm going to ask you might be proprietary, so if you can't answer it, I understand that. But can you talk at all about the approximate load factors, how much graphene? Because I want to come back to that recycling question. The fact is that very small amounts of graphene are actually added. So it's not like you've got, 5 or 10 or 15% of the material is graphene. It's much less than that. Can you describe how much is in there roughly without giving any away trade secrets?
Yeah. Well, I guess the first part you were talking about was cost. So let's cover the cost one first. So because we've got a database built up of a couple to 300 nanomaterials now, we don't just QC them to understand the mechanical properties and how they are. We also vet them for commercial suitability. So within the composites, like the tooling and the mechanical, for instance, we use a very good lower cost material. Because we functionalize it, we alter the surface chemistry, which gets it to perform better. We get it to do what we want it to do, but we also keep the cost down in that process. So that's how we do it from that side of it, the commercial side. Now, when you see the conical flask video and the functionalization actually gets the nanomaterial to behave differently, we only need to put a very small amount in because it's been tailored to the carrier, and it's also tailored to the application. So when you talk about traditionally filled resins and filled products, we still have customers saying 20, 30, 40%. How do we do that? And we say, no, it's a fraction of that. It's an absolute fraction. It's, in most cases, it's sub 5%.
Yeah, we've seen, in fact, when we did our own testing, the Graphene Council ran a composite testing project. We did 0.5% and 0.1% by weight. And in fact, the 0.1% performed better. So using less actually gave a better result in a two-part epoxy testing that we were doing for the composite sector. I think that's quite interesting. Simon, there's a point I don't want to lose on the audience. Now, Haydale doesn't actually produce graphene. That's right?
Correct. We work with all the graphene providers in the market. We are completely independent, which means we select the correct material for the job. We're not bound to push a graphene that may not be optimum into an application because we're tied to the graphene supplier. We do it the other way around. We work backwards. We find that there's a problem, then work back through the solution. That's what we do. We provide functionalized nanomaterials fit for purpose.
Well, I think the amount of knowledge that Haydale has accumulated over the last 15 years, almost 15 years, certainly more than 10 years, and having seen more than 200 graphene forms shouldn't be underestimated. The Graphene Council, likewise, we're neutral. We test materials, we characterize, we've written standards. We also understand, and for the audience, for those of you who are maybe not intimately familiar with graphene materials, small changes in the number of layers of carbon, the lateral size, the chemical composition, impurities, and whether or not the material is functionalized, which is the expertise that Haydale applies, all affects how the graphene performs. So this knowledge you have, I think, is often underestimated how valuable that is. What it also means, because you work as a toll processor, if you have a company that's, let's say, engaged with a graphene company, they can also bring you in as a partner on the functionalization part of that. So you have a good graphene supplier, you have an end user company, and you want to solve a technical engineering issue with getting the graphene dispersed and to unleash some of its properties. How often does that happen? Is that a typical scenario?
It's becoming more regular than you would think.
Yeah,
a lot of companies have experienced the left conical flask where they've tried to blend nanomaterials and it doesn't work. It contaminates systems. We still get feedback that, oh yeah, we tried it a few years ago. That's what we encountered. How do we overcome it? Okay, come and talk to us. But we will work with anybody that's got an issue and they think functionalization can help.
I can only echo what you say. We've done a lot of work in the composite sector. We partner with JEC World, we partner with ACMA, with Camex, and we've heard the same thing. Because graphene got such excitement a few years ago, a lot of companies, tested it. They would ask for a sample and they would play with it, right? And what we've seen is when graphene doesn't work, it's usually one of three things or all three. They didn't get real graphene in the first place, right? So it's not the material, but they didn't get the material they thought they were getting. They didn't understand how to disperse it into the matrix, and that's where the functionalization comes in. And they didn't understand how to apply the right load factor, where, if they didn't get a good result, the intuitive thing would be, okay, let's add some more in, when typically for graphene, it's the opposite, right? You want to use less. Yeah. So I think what I want to say is for anybody out there who's tried graphene before and it didn't work, even if it was 2 years ago, things have changed dramatically with the number of qualified suppliers, with the expertise that's there, and the understanding of how to apply this. Let's take a couple more questions here from the folks that are paying attention to this webinar. One of the questions is, not all composite tooling is made with epoxy, but rather many use UPR or VE-based materials, like in marine applications. Can this HD Plas, the functionalization, be used for those UPR and VE resin systems and gel coats?
In short, yes, it can. Generally, we talk about epoxies because that's what everybody uses and that's what we've done in the past. But we have master batched into countless different resins and carrier systems now. We've done composites work in parts in vinyl ester, in polyester. So the knowledge is transferable. It may need to be tweaked a little bit just to get it to work, but that's not uncommon. But yeah, in short, yes, it can go into different systems.
Excellent. We have a couple of questions that are similar. One is asking, what is the prognosis? Where do we see this going? And also, would we consider that adoption of this has been fast or has it been slow? And, my question would be, well, let me put the context around it. As the Graphene Council, we're an independent body. We don't make graphene. We don't sell graphene. We simply monitor, we write standards, we characterize, we test, we verify companies. So we observe this, and we've been doing this now for more than a decade. From our side, it is crystal clear with examples like you've just presented. Graphene actually works with significant improvements with a small amount of material. So the question is, why isn't everybody using this, right? Why isn't everybody rushing to it? I have some ideas, but how would you answer that, Simon?
I'm a little aghast as to why people aren't adopting this quicker. And, for the last three sort of slides where we laid out, is it green? Is it cost effective? Is it commercially available? Is it going to help you? Is it cost effective? All these answers are in there. And, if I would encourage companies to try it. And, the proof is definitely in the pudding, but, we can only demonstrate it to you so far. You've really got to get on board with it. And I don't know why companies are not really chomping at the bit for this. I think it will with more exposure, with presentations like this, but, it works. It's available.
Yeah.
It's not a lab scale thing. This is commercially available and has been for some time. Now that we're seeing the numbers sat behind it to prove the concept. Yeah.
I think what's clever in what you're doing is, this is not something that the customer has to worry about doing the compounding or, getting the load factor. It's already in a prepreg, right? So they can just pop it right into their system. And we do know from other companies, there are graphene-enhanced resin systems coming to market. There are going to be other prepreg products coming to market. So you guys, I think, are leading with this application, but there certainly will be more out there. Let's see if we can, because we've got quite a few questions now coming in. So what is the enhanced thermal conductivity with respect to through thickness and in plane properties? Is this changed for each application, and how do you control the thermal conductivity?
Interesting. Probably a little bit above my pay grade, but I'll give it a shot. So we control the thermal conductivity by the loading levels. So with things like electrical and thermal, it's a linear process. The more you put in, the more conductive it gets up to a certain point before you destroy the mechanical performance of the resin through viscosity. So it can be controlled and it can be tailored and tweaked. That's the dilution ratio between the master batch and the final resin that dictates that. But customers can play with it. If they need something really conductive, then we have products to go that way. If they're happy with what they would see in this system, stick with the standard. But we often bespoke resin systems for customers. So it's not a problem.
And in this case, you're talking about carbon fiber reinforced parts, correct?
Yes.
And what about glass fiber or basalt or any of the other fibers?
So long as the resin system is compatible with the reinforcement that you're using, you can nano-enhance the resin system to do what you want it to do, really, across those three groups. I won't say it's an easy process, but it's pretty well understood now that if you say, okay, I want to make a basalt something or other and I want it mechanically enhanced, you can take those two things and marry them up into a prepreg.
Yeah, absolutely. So we're talking about graphene nanoplatelets. What about graphene oxide? What kind of work have you guys done with GO or graphene oxide material?
Quite a lot. It sits within that characterization catalog of materials that we do use for applications.
And we also get questions from the audience about other applications other than this one. I think, what we wanted to focus on was this application, because this is real world. This is in a shop. It's being used. It's more than doubled the life of this tool, which the customer has confirmed, and they've confirmed that not only has it doubled the life of the tool, but the quality of the parts have been improved compared to its legacy or traditional tooling. Haydale has worked across a lot of different applications. So we have people asking about, graphene and plasma-enhanced graphene for things like water purification, for coatings, for other applications. Can you give just a really high level, what is the depth and range of applications you guys have experience with?
That's a good question, and it is a very broad answer. So predominantly, there are several groups that we work in. So we work in thermosets, composites, thermoplastic composites, straight thermoplastics, elastomers, so processing oils, rubber compounds and master batches. We work in graphene-based inks for biomedical applications, sensors, heating elements, wearables. Honestly, it's that broad, and you can adopt functionalization to do a lot of things. So, it's almost like a recipe book of chemical groups that we can apply to different nanomaterials. So my response to that would be reach out to us and ask the question. Yeah. If you've got an application, just put your hand up and ask, have you got any experience here? And the likelihood is yes, over 10 years of functionalization development we have.
Excellent. Yeah, we've seen graphene as extremely versatile. From the Graphene Council perspective, we've identified at least 45 vertical markets for graphene. And we do have, a large community. We reach more than 35,000 materials professionals within the Graphene Council community. I think, Simon, with that, we're gonna conclude today's webinar. I think this has been really on point. I think it demonstrates clearly the value of using this material and the expertise that Haydale has in this this particular skill set of functionalizing different graphenes means for you as a customer, for those of you who might be interested in this, you have flexibility of sourcing graphene from basically any supplier of graphene. Haydale doesn't produce graphene, but they enhance it, functionalize it, and you can work together on that application development for your particular application. And I'd invite you, if you're not already receiving the Graphene Council's weekly Graphene Intelligence Briefing, you can sign up for that for free. If you'd like more in-depth information or help with anything related to graphene, you can contact the Graphene Council for that as well, for independent third-party consultation. And we'll pass Simon's contact details with his slides following this presentation, along with a link to the recording so you can play on demand or share that with colleagues. You're free to share any of this information as widely as you like. And we really encourage you to reach out to Simon at Haydale if you have any queries about how to apply this technology, or how do you get your hands on the prepreg material, which is available in the market today, so you can use it. And there was a question, is this just for tooling? We've said it a couple of times. This isn't just for the tool. It's excellent for the tooling, but it's obviously also for the composite parts, whether they be carbon fiber, glass fiber, basalt, or any other kind of a composite. And with that, Simon, do you have any closing remarks you want to share with our audience?
Nothing really, apart from if you've got an application where you think this can help, please give us a call. Try it.
Excellent. Well, thank you for your time. Thank you for sharing your expertise. And thank you to everybody who tuned in today for the webinar on this topic. And I hope it was educational and informational for everyone. And with that, thank you. Have a great day.
Thank you.
For more information and to connect with expert partners, contact the Graphene Council at thegraphenecouncil.org.